Good afternoon. I think the last of my big storms has come through, so hopefully I keep my power and we can get this video recorded here. I'm breaking this section 9.3 into two parts, and again I'm going to stress to you the assignment that I'm giving for this part right here is not going to be due next Monday. I want to meet next Monday and clear up any questions first, so I'm pushing this off a week, the assignment due, but don't put it off because you're going to need it next week. So I want you trying this and we'll clear up any questions on Monday. So we're starting rates of change, but we're going to transition from average rate of change to instantaneous rate of change. And where that comes in is going to allow you to more accurately calculate marginal revenues, and this is going to tie into what we did back in the linear situation, but now we're into more involved functions. So average rate of change, that's what we compared to with linear functions. We compared that to the slope of the line, and when we looked at marginal revenue or marginal cost, all we did was pull the slope out, and that gave us that value. Well, now once we get into higher degree situations, we're going to have to use a little different format here. So if it's not linear, all right, we're going to have to go in here and look at it in terms of instantaneous to get our marginal revenue situations. But right now I want to transition first from the average rate of change. And all I've got here, and you can see this on your copy of your notes that I posted for you, all we're doing now is taking F of B minus F of A, which is Y value minus Y value, all over B minus A, which is X value minus X value. So that's still technically slope. All right. Now, the problem is when you look at the graphs of these non-linear functions, they're no longer with segments of lines that we're looking at. We're looking at curve situations here. So what's happening is if I have this point down here, this is A right here, and this is B right here, I'm looking at this point on the curve and I'm looking at this point on the curve. And you're going to say, well, gosh, Riff, that doesn't really look anything like the graph. But if I choose A and B to be that far apart, what's happening here is I'm going to form those 2 points will form what we call a secant line that cuts through the curve. Now, eventually what we want to do is have A and B so close together down here that it'll almost look like it's not so much of a secant but a tangent line. But baby steps, we got to get there through this process first. So that's what's going on there. So if we move on down here, and I'm going to have to move my paper up so you can see it here. All right. So we're going to talk about finding average rate of change in your revenue first. All right. So we've got a function here. They've given us a revenue function, and you're going to notice it's quadratic. All right. So in that situation there, it says where X is number of units sold, and it is a quadratic function. All right. So they're talking about finding the average rate of change for revenue from 50 units being sold to 60 units being sold. So, well, we've got X equals 50, and we also have X equals 60. Well, this is your A in your formula, and this is your B in your formula. All right. So what we have to do is find R of A, excuse me, I should say R of B, and we need R of A. Because what we're going to do here now is average rate of change is going to be R of B minus R of A all over B minus A. So what I'm going to do is basically, I'll just show you here what I'm doing. I'm plugging in A to be 50 here. So that means I want the function R evaluated at x equals 50. So when I go in there, that's 82 times 50 minus 0.08 times 50 squared. Now, to save time here, just to help you out here, what I did was I calculated that. So R of 50 comes out to be 3,900. R of B is going to be R of 60. And when I plug that in, that's 82 times 60 minus 0.08 times my 60 squared, which comes out to be 4,632. So I have everything that I need there, so I'm just going to plug my information in. So R of 60, R of B is going to be that 4,632 minus my R of A, which is 3,900, all over B, which is 60 minus 50, which gives me 732 over 10, which is 73 2/10. Now, what does that mean? Okay, so what we're looking at right now, and it's kind of hard to compare average to instantaneous revenue margins here. So I'm just kind of giving you an idea, is that's what the average revenue will be if you would sell 61 units, all right, or in your next 10 units of a blender here. So what's going to happen here is you're going to see this change as you go through different amounts of items being sold, etc. All right, so that's what we're doing for average rate. All right, so this is the same approach when you were taking the average. You do this for any kind of average rate of increase, and I am stressing the word average here. Rate of increase, decrease. If you were doing average velocity, you do the same thing. And it's because you're doing it over a particular interval, which will do that for instantaneous. But here's the deal for average, okay? This is the little formula that you're going to use. So they may ask you something with just a generic function here, not applying it to any particular problem situation. So they're giving me f of x is equal to 30 minus x squared over the interval x equals 1 through x equals 4. So there's my a. So my a is 1 and my b is 4. All right, so I'm going to find my average rate of change. That's going to be equal to f of b minus f of a all over b minus a. So we need to find f of a. So f of a is equal to f of 1. All that means is I'm going to go back to this function f of x and plug in x to be 1. So that's going to be 30 minus 1 squared. Well, that's just going to give me, well, I'll keep it away from this over here. So we're going to get 30 minus 2, which is 28. We need f of b as well. So that's going to be f of 4. So that's going to be 30 minus 4 quantity squared. Well, that's going to give me 30 minus 4 minus 16. Well, 30 minus 4, 26, minus 16 should give me 10. So there's my f of b. All right, so for my change here, I'm going to have f of b, which is 10 minus f of a, which we said was 28, all over b, which is 4, minus a, which is 1. So what we're getting is 10 minus 28, which is negative 18, over 4 minus 1, which is 3, and negative 18 over 3 is negative 6. Now, I'm not going to go into what that's talking about graphically just yet. I'm going to save that for my video. Just kind of chill there, and you should be okay. All right? Moving on. So now we get to this instantaneous business, all right? If it's an instantaneous rate of change, and I'm going to really start talking about velocity first because it kind of makes more sense. For an example here, all right? When we toss a ball straight up, all right, what happens is you have an initial velocity that when you release the ball straight up, and remember, if it's projectile motion, it's straight up and it comes straight back down. So you're not projecting at an angle or anything here. Straight up. Well, what happens is when it reaches, because of gravitational pull, it's going to reach a maximum height. It's not going to just keep going because it's not going to float away. Gravity is going to pull it back down. So in that situation, as it gets up to that maximum, your velocity is going to change. At the very instant that it reaches its top height, your velocity for that instant is 0 because it's now going to change and have a negative velocity in terms of the fact that it's coming back down. All right? So suppose we have a situation here, and this is what I want you to understand. We're going to look at this situation here, and if we represent the change in time by h, then the average velocity from x equals 1 to x equals 1 plus h. Okay, so this h could be anything, all right? It's just a change in time. And if I want that time to be really, really, really small, that time change, to make it instantaneous, almost like every blink of an eye, I want a really small value for h. Now, this is the truth. It'll approach 0, but it could be a positive value, really, really, really small. It could be a negative value, really, really, really small, just like we were talking about in class the other day. So they've given me this function here for this ball thrown straight up, and I'll just kind of explain it to you here. Normally you would see it written as negative 16x squared plus 64x plus 96. Now, I'm fine with it left the way they had it, but I'll just explain. This negative 16 is because we're working in feet, all right? So that's allowing for your gravitational pull. Your initial velocity is 64 feet per second, and then your initial height that you started with was 96 feet up above the ground, all right? So that's just basically what it would be talking about here. So what they're going to ask you to do here is, where x is the time in seconds, so we're talking feet per second movement of this. So it's going to ask you on part A to find the average velocity from x equals 1 to x equals 1 plus h. Well, here's where we're going, all right? So I'm going to look at part A here first, all right? So part A is talking about the average, all right? So I'm going to call this velocity sub av, all right? So that's a V down there, sorry, kind of sloppy. All right, so in this situation, my A in my little formula that we've been using is simply 1, all right? That's where we come from here. And my B is 1 plus h. All right? So what we're going to do is say velocity average is equal to f of B, which is 1 plus h, minus f of 1, all over b minus a, which would be 1 plus h minus 1. Okay, so what we're going to do here is first we have to plug in x plus h for that crazy function up there, all right? So I'm going to come off to the side over here and just show you what I'm saying. F of x, 1 plus h. Oh gosh, I was going to do x plus h. My goodness, 1 plus h, all right? So what we're going to do here is show you, and part of your homework is going to be just filling out problems like this, all right? So that means I have 96 plus 64 times the quantity 1 plus h minus 16 times 1 plus h quantity squared, all right? Messy, messy, messy. So that's equal to 96 plus, I'm going to distribute my 64 in, so it's going to be 64 times 1, which is 64, plus 64h minus 16. Now, when I talk about 1 plus h squared, 1 plus h squared, that's me taking 1 plus h times 1 plus h. I don't just square the parts. So you're foiling it out. So what that comes out to be is 1 plus 2h, because you have one h and you have another h, plus h squared. All right? So that's going to be minus 16 times the quantity 1 plus 2h plus h squared. I'm sorry that's so small there. All right, so let's just clean that thing up. So we've got 96 plus 64. Okay, we can add those two together. But I'm just going to write it all out for you here. So that's 96 plus 64 plus 64h minus, now I got to distribute this 16 in. So that's minus 16 minus 16, so I've got 16 times 2h, so that's minus 32h. And then we have minus 16h squared. All we're going to do is clean that up. And I know it's the arithmetic more than anything, all right? So we've got 96 plus 64 minus 16. Well, 96 plus 64 is 160 minus 16. That gives me 144, so I've taken care of those. Then we've got 64h minus 32h, which is leaving me with 32h. 64 minus 32 is 32. And then I have minus 16h squared. Okay, so that's what goes in for all of this right here. Just that is that business right there. So what I have now is 144 plus 32h minus 16h squared minus f of 1. Well, I've got to calculate f of 1. Well, that's where we're plugging in 1 for x. So that's 96 plus 64 times 1 minus 16 times 1 squared, which is just going to give me 96 plus 64 minus 16. 1 squared is still 1, so that's minus 16. Well, it should sound familiar because that's 144. So we're going to subtract 144 there, and that's all over. Now, here's our denominator. You have 1 plus h minus 1. Well, the positive one, the negative one negate each other, so all we have is h. Okay, so let's just clean her up. So what we've got in the numerator is 144 plus 32h minus 16h squared minus 144 all over h. The situation with the 144, they're gone. And what you're going to notice is every term up here in the numerator that's left is going to have h in it. So let's factor it out. So that's h times, 32 minus 16h all over h. Right? So the h is reduced, so my velocity average is equal to 32 minus 16h, and that's feet per second. So whatever my time frame was going from 1 to 1 plus h, if that was 1 to 1.1, I would be plugging in 0.1, and that would tell me what my average velocity was per tenth of a second, if you will. All right, but I have to remind you that's average. All right, now this is what you need to understand. For average situations, unless they ask you particulars, all you're doing with that h information there, if they don't give you a value for h, you leave it be. So your velocity average would be 32 minus 16h feet per second, and that's how you leave it. Now, I'm going to transition into part B here, which is instantaneous velocity. Well, it's pretty cool because if I want to do the instantaneous, the hard work's done, because my velocity for instantaneous, and we just call it v, all right, is nothing more than the limit as h approaches 0, because remember, I want this h value to be really, really small, so it looks like no change really in time at all. Very, very, very small time change of 32 minus 16h. So this information is going to come up and be the function of your limit situation. Now, we talked about this the other day. I've got a polynomial function there in terms of h. There's no denominator or anything like that. So all we do is evaluate it for h equals 0. So that's going to be 32 minus 16 times 0, which is 32 minus 0, which is 32 feet per second. And you're done. So that's the easy part of it, all right? The work is coming from you doing that formula for the average. So, brings us down to the next part here. So if you're looking at this little box down here, it's just basically information. So if I'm working with instantaneous rate of change, all I'm doing is taking that slope formula that you've been working on for average and the limit as h approaches 0. That's it. All right? So if you come down here, it's saying, guess what we're going to call this, though? That instantaneous rate of change is what we refer to as our derivative. So you've entered the world of calculus formally now because we're talking about the derivative. Now, I'm just going to be honest with you. Yeah, it looks time consuming, but bear with me. You will not be doing this long, involved process for all that long. So it will get better, but you got to understand it first. All right? So this is all just explanation of what we were talking about up there for your instantaneous velocity. All right? And all I'm pointing out is you're going to use the limit of it. That's it. All right. Next page. Now, I am so sorry that this kind of, I wish I could zoom in on it, but I can't really. I don't think I can. I'm going to give it a shot here and see if my camera will let you see it a little better here. There it is, if you can see it. This is on page 562, 563. I took the information right from there, so that's what it is right there. I didn't realize it was going to show up so small. But this is just another example of you finding the derivative. So if they ask you to find the instantaneous rate of change, what you're finding is your derivative. That's it, all right? And I'm going to take you through this. So I'm going to show you an example down here. All right, the other thing I want to talk about here is you're going to notice that they're going to use this little this is your derivative. All right, they use this little shorthand. We call it f prime. Now, first derivative is one little hash mark here. All right. If we do a second derivative, it gives us more information. But first derivative, we call it f prime. If it was a second derivative, it would be f double prime, etc., etc. All right. Other names for it. dy dx, that's the change in y over the change in x. Nothing more than slope. They'll call it y prime. They'll call it d dx of f of x. They'll call it dx or yx or d of f of x. I tend to just use this. That's your derivative. Some other books will talk about delta, dy dx with delta, the little triangle, but this is the easiest one to write. All right, it's the easiest one to write right there. All right, so I'm going to take you through what they'll ask you in a problem situation. Let me realign my little camera here first. There you go. Okay, so let's look and see what we've got here. So it says, for the function f of x is equal to x squared minus x plus 1, find the following. So what I'm doing here is breaking it down and taking you through it step by step, because if you look here, I'm doing the numerator portion of our average rate of change over, just putting it over h here and simplifying, and then I'm taking you to the derivative, and then I'm ask you to evaluate. So that's what you're seeing there. I don't know if you can see the little hash mark very carefully there, but I'm asking you for f prime of 2. So I'm going to take you through the whole thing. All right. So first thing we want is f of x plus h minus f of x. Well, that's nothing more than going to this, and every place that I see x, the first time through, I have to put in the quantity x plus h. So that's going to be x plus h, quantity squared, minus the quantity x plus h plus 1, minus what f of x is. But I'm subtracting all of this, so you'll notice my parentheses are necessary here. X squared minus x plus 1. Don't try to be a hero and do a bunch of this in your head. It will come back to bite you, I promise. Now, the x plus h, remember that's x plus h times x plus h, which is going to give me x squared plus, 2xh plus h squared. Now here I'm going to distribute the negative in, so I'm going to have minus x minus h plus 1 minus the quantity x squared minus x plus 1. Let's just clean this up if there's anything in there to combine any like terms. Doesn't look to me like we have any like terms. So we've got x squared plus 2xh plus h squared minus x minus h plus 1. Now you need to distribute negatives again. Minus x squared minus a negative x is plus x minus 1. Now, all I'm doing is cleaning that up. Let's look for any like terms. I've got a positive x squared and a negative x squared. Gone. I've got a negative x and a positive x. Gone. I've got a positive 1 and a negative 1. Gone. So what are we left with? We are left with 2xh plus h squared minus h. Okay, so where do we go from there? Well, can we factor anything out there? Well, let's just go down to our problem number 2, because that took care of that part right there. And I'm going to put it in, I tend to write these in descending order. That's just me. So h squared plus 2xh minus h all over h. Okay? So what can we factor out? Well, everything up here has a factor of h, so let's factor it out. So h times the quantity h plus 2x minus 1 all over h. Well, the h is reduced, so what we're left with is h plus 2x minus 1. Well, that right there is what goes in here. So that means we've got our derivative, this is the derivative, is equal to the limit as h approaches 0 of h plus 2x minus 1. And again, I've got a polynomial, so all I'm going to do is plug in the h. So that means 0 plus 2x minus 1. So f prime of x, my derivative, is equal to, well, the 0 minus 1 is negative 1, so I have 2x minus 1. So down here, if they're asking me for f prime, I'll write it bigger for you there, f prime of 2, all I'm going to do is take this function, and where I see x, the new derivative function that I got, I'm just going to plug in the 2. So that means I've got 2 times 2 minus 1, which means I've got 4 minus 1, so f prime of 2 is equal to 3. That's it. Now, I took you through the whole step-by-step process there, all right? So use that to help you go through. I didn't give you that many problems yet because there's a couple things that I just want to mention in there for you. But I want to take you through step-by-step here so that you can use it on the problems in your homework, all right? And feel free to come back and look at the video again. That's fine. All right, so our last page. So here we are. Like we said, the marginal revenue when we had linear functions was MR bar. We said that that was our marginal revenue, but all it was the slope of the revenue function. That's because you were using the rate of change for which is the slope of a linear situation. Well, we're no longer with linears anymore. So what we're going to do is find an instantaneous rate of change, and guess what? It's nothing more than your derivative, your limit situation, all right? So I'm just going to show you here, and they do put the qualifier here, provided that the limit exists. In these situations, if I'm still giving you polynomial functions for right now, the limit has to exist. We always have a continuous function for polynomials. So if you'll notice here, I've given you a situation. The total revenue function for a home stereo system is R of x is equal to 250x minus x squared dollars, where x represents the number of systems sold. All right. So if that's the case, what is the function that gives the marginal revenue? All right, well, marginal revenue is nothing more than R prime of x. Well, that right now is our limit as h approaches 0 of R of x plus h minus R of x all over h. Now I'm going to come down here and do the work there so you can see it. All right, so I hope you can read this. Sorry, I've got shadows coming in on my paper here. Finally, the storm has ended. All right, so that means the first time through where I see x up here, I've got to plug in x plus h. So that means I've got 250 times the quantity x plus h minus x plus h, quantity squared, minus r of x, which is the quantity 250x, minus x squared. And that's, excuse me, I forgot to put my limits in. I always do that. I get in a hurry here when I'm trying to show you here. I need to put my limits information out there. The limit as h approaches 0 of that all over h. All right, so let's clean her up. So that's the limit as h approaches 0. I'm going to distribute that in, so that's going to give me 250x plus 250h minus the quantity. All I'm going to do is square this. That's x plus h times x plus h. We've been doing that. So that's going to be x squared plus 2xh plus h squared minus the quantity 250x minus x squared all over h. Please take your time on it. So that's the limit as h approaches 0 of 250x plus 250h, distribute in, minus x squared plus, minus 2xh minus h squared. Distribute your negatives in here. So minus 250x minus a negative is plus x squared, and that's all over h. All right, so let's clean her up. I'll move this up a little bit so you can see it. All right. So that's the limit as h approaches 0. All I'm going to do is look for like terms that negate each other here. So the 250x, the negative 250x, gone. I have a negative x squared, and I have a positive x squared, gone. All right, so what are we left with? Well, we're left with 250h plus 2xh minus h squared all over h. And you're going to notice it again. Every term in your numerator's got a factor of h. Let's factor it out. So that's the limit as h approaches 0 of h times 250 plus 2x minus h all over h. And these two are going to reduce. So what we're getting is the limit as h approaches 0 of 250 plus 2x minus h. Well, all you're going to do is plug in h to be 0. So that's 250 plus 2x minus 0, which is 250 plus 2x. Now, what they want to know is what is the marginal revenue. So this, I'm going to call it here r prime of x. That's our, which is our marginal revenue. All right. So they're asking us up here on part B, they're asking us what's the marginal revenue of 45 systems. Okay, so that means I want r prime of 45. So all I'm going to do is take that formula that we came up with down here, our little, all right, so they want r prime of 45, so that's 250 plus 2 times 45. Well, that's 250 plus 2 times 45, which is 90, which is going to give me 250 plus 90. What do we get? Did I lose a sign somewhere? Oh my, where are we? 2x. I'm just checking my work here, people. Hang on. Plus 2. I just double check here. That should be minus 2x. And I'm just looking to see where I lost my sign here. Minus 250x plus x squared. Just double checking. There it is, right there. Yep, that should be minus 2x. My bad. That's my bad. There we go. Glad I caught that before you started this homework. Okay, so that should be, yeah, I was going to say that's kind of high for our revenue. What's 250 minus 90? Well, that's 160. So what does that mean? Because they're going to ask you this. They're going to ask you, what does that mean? Well, it's saying if I'm selling 45 systems, the marginal revenue, what it's telling me is this is the estimate of revenue on selling my 46th system. So that's basically what you're doing. You're trying to estimate what, if I'm selling plus one, because you can't sell a part of a system. But if I sold one more system, what would my average rate of change in revenue be? It would go up 160. That's it. That's all it's asking you. All right. So for right now, I know it's kind of an abstract idea there, but that's what they're asking you. What does it mean? It just means for, the next item that I would sell, what's my instantaneous rate of change in my revenue? That's it. My marginal revenue. So my marginal revenue for the next system would be 160. That's it. So that's what you're doing. I haven't gone through all of this section yet, so I just want to give you that part of it there, and then I'll explain the rest of it. So you're going to notice on your homeworks that some of it says A and B only. That's because there's a part C to those problems, and I haven't shown you that part yet, so I will explain that on Monday. All right, so stay safe. I'm hoping the storms have calmed down now, and I will hope you have safe travels home if you're going home for Easter. And I shall see you on Monday. Take care.